SpaceX has truly changed the game of space travel. For decades, rockets were used once and then discarded. SpaceX pioneered making parts of rockets reusable, which was a monumental step forward for the industry. This innovative company is led by Elon Musk, a figure known for his bold ideas about humanity's future among the stars. We are witnessing the dawn of a new era in space exploration, one filled with immense possibilities. So, what exactly is this Starship we hear so much about? Imagine a colossal spacecraft, the largest ever conceived and built by human hands. This is Starship, a project of SpaceX. It is meticulously designed for missions of an unprecedented scale. Its primary purpose will be to carry both human astronauts and vast amounts of cargo. Starship is engineered not just for Earth's orbit, which is a common destination for many spacecraft. It is also designed to travel much farther, to the Moon, and most ambitiously, to Mars. There is even the potential for it to venture deeper into the solar system, a truly ambitious undertaking for any space program. Starship is not a single piece of hardware. It comprises two essential and massive parts. The first of these is called the Super Heavy Booster. The second critical component is the Starship upper stage. Both of these stages are designed with full reusability in mind, a cornerstone of their innovative design. Starship aims to provide precisely that capability, representing a giant leap in space technology. Let us take a closer look at the Super Heavy Booster, the first stage of this magnificent machine. This booster is an engineering marvel in its own right. It stands incredibly tall, approximately 232 feet, or about 71 meters. Its sole purpose is to provide the initial colossal push needed to escape Earth's gravity. The Super Heavy Booster achieves its extraordinary power through a multitude of advanced engines. It is equipped with an astounding 33 Raptor engines, all clustered at its base. These Raptor engines are a SpaceX innovation, developed in-house and known for their high performance. They consume a combination of subcooled liquid methane and liquid oxygen as propellants, a choice made for efficiency and potential for in-situ resource utilization on Mars. Working in concert, these 33 engines generate over 16 million pounds of thrust at liftoff. Now let us turn our attention to the Starship upper stage, which serves as the second stage of the launch system. This component is also exceptionally large, measuring around 171 feet or 52 meters in height. It is engineered to carry over 100 metric tons of cargo to low Earth orbit. Furthermore, it is designed with the capacity to transport up to 100 people on long-duration voyages to the Moon or Mars. The Starship upper stage is also powered by Raptor engines, though fewer in number than its booster counterpart. This sophisticated engine arrangement allows the Starship upper stage to operate effectively across different environments. Perhaps the most profoundly revolutionary aspect of the entire Starship system is its design for full reusability. This means that both the Super Heavy Booster and the Starship upper stage are intended to be recovered, refurbished, and reflown many times. Most rockets throughout history have been expendable, meaning they are used only once and then their expensive components are discarded. This expendability is the primary reason why space missions have traditionally been so extraordinarily expensive. Starship aims to completely overturn this costly paradigm. To understand the impact of reusability, consider the analogy of commercial air travel. Airlines do not discard a massive aircraft like a Boeing 747 after a single flight. Instead, they refuel it, perform necessary checks, and fly it repeatedly. This is precisely the operational model that SpaceX envisions for Starship. If rockets can be reused as frequently, quickly, and reliably as airplanes, the cost associated with launching payloads and people into space will decrease by orders of magnitude. Such a dramatic cost reduction could democratize access to space, opening it up for a much wider range of scientific, commercial, and exploratory activities. Starship is not only designed to be reusable, but is also engineered to be incredibly powerful and capable. It is on track to become the most powerful launch vehicle ever successfully flown, surpassing all predecessors in terms of liftoff thrust and payload capacity. The combination of drastically reduced launch costs and vastly increased payload capability offered by Starship has the potential to fundamentally transform humanity's relationship with space. Starship is truly the enabling technology, the key to unlocking these and many other exciting possibilities in a new era of cosmic exploration. Elon Musk, the visionary founder of SpaceX, has a clear goal for the Starship program. He aims to make humanity a multiplanetary species by establishing a colony on Mars. Starship is designed to turn this dream into reality. It will ferry pioneers and supplies to Mars. Closer to home, Starship will aid lunar exploration. NASA selected Starship for its Artemis program to return astronauts to the Moon. Starship will also deploy satellites for various purposes. Developing Starship is a challenging endeavor, pushing the boundaries of science and engineering. SpaceX uses an iterative design process, rapidly building and testing prototypes. Test flights are crucial, providing invaluable data and insights. Early prototypes like SN8 and SN15 faced various issues but were critical learning opportunities. This rapid build-test-learn approach is different from traditional methodologies. Let us now turn our attention to a specific instance in the Starship test program, the event referred to as Starship Flight 9. This particular uncrewed test flight took place in early 2024. As with all other developmental test flights, its primary objective was not necessarily to achieve a perfect mission profile, but rather to gather critical engineering data. These tests are designed to push the vehicle's systems to their operational limits, and sometimes beyond. The goal is to gain a deeper understanding of how the integrated Starship system performs under actual flight conditions. During the ascent phase of Starship Flight 9, a significant problem emerged. A malfunction reportedly occurred in one of the Raptor engines powering the vehicle. These engines are fundamental to the rocket's ability to generate thrust, maintain its trajectory, and control its orientation. The unexpected loss of performance or complete failure of even a single engine in a multi-engine cluster can have serious and cascading consequences for the flight. It can lead to a reduction in overall thrust, potentially causing the rocket to deviate from its planned flight path. It can also critically impact the vehicle's stability and its ability to remain under control, especially during high dynamic pressure phases of flight. The reported Raptor engine malfunction during Flight 9 ultimately led to a loss of control of the Starship vehicle. This critical failure occurred during the ascent phase while the rocket was still powering its way towards space. When a large and complex launch vehicle like Starship loses control at high speed and altitude, it is often impossible for it to recover or for ground controllers to regain command. Consequently, the mission objectives for that particular flight could not be achieved. Following the Starship Flight 9 incident in early 2024, SpaceX embarked on a comprehensive investigation. Engineers analyzed data to determine the Raptor engine malfunction. They swiftly implemented design improvements. Manufacturing techniques and quality control were refined. The goal is to enhance the robustness and reliability of Starship. This cycle of test, learn, and improve is their strategy. Flight 9 is part of an extensive test program. Each test flight contributes to the vehicle's evolution. Other flights have shown significant successes. The sixth test flight showcased progress in key areas. It demonstrated Raptor engine restarts and heat shield performance. The Super Heavy booster had a controlled splashdown. Recent uncrewed flights provided invaluable lessons. In early 2025, Starship experienced anomalies. The Super Heavy booster achieved precise splashdowns. Elon Musk's ultimate ambition with Starship is clear and audacious. He aims to establish a permanent human presence on Mars. Musk envisions a thriving Martian city, a new branch of human civilization. This mission fuels SpaceX's relentless efforts and the creation of Starship. Musk believes humanity becoming multiplanetary is essential for survival. Starship is the transportation system to make this vision a reality. The timeline for Mars missions is exceptionally ambitious. Musk plans an uncrewed Starship mission to Mars by 2026. Human expeditions would follow in subsequent launch windows. Before Mars, Earth's moon is an important stepping stone. SpaceX is a critical partner in NASA's Artemis program. SpaceX is developing the Starship human landing system for lunar missions. This vehicle will ferry astronauts from lunar orbit to the moon's surface. The target for crewed lunar landings is around 2026 or 2027. These lunar missions will test critical technologies for future Mars missions. Starship represents a monumental leap in space technology and exploration. Its full and rapid reusability promises to alter the economics of space access. The powerful Raptor engine aims to make space travel more economical. Like early aviation, Starship could transform space access. The journey is fraught with technical challenges. Each test flight, even failures, provides invaluable data. SpaceX's iterative development embraces these challenges. Achieving reliability for human missions to Mars is paramount. Elon Musk's vision is to transform humanity into a multi-planetary species. Starship is the embodiment of this dream. It symbolizes human ingenuity and our desire to explore the unknown.